An Analysis of New York City's Air Quality by JRupp. Introduction. Air quality is a highly important topic. Poor air quality can lead to health issues and can worsen pre-existing conditions such as asthma and/or any lung condition, and this could lead to possibly hospitalizations and/or death. Therefore, New York City's air quality was analyzed. The data was collected over a number of years from different spots in New York City about different, air quality factors such as nitrogen dioxide and/or fine particulate matter. The goal of this project was to analyze New York City's air quality and correlate the air quality to hospitalizations related to fine particulate matter, and also see if there was any values related to fine particulate matter that could predict it. And so here are some important terms. For instance, fine particulate matter measured in micrograms per cubic meter is going to be listed as FPM. And then fine particulate matter attributable asthma emergency department visits will be named FPM AAED, and then ozone will be listed as O3. And for the pre-processing, the dataset had some unnecessary column names. For instance, the measure info, the GeoJoin ID, and the message were kind of unnecessary. While they are necessary to fully understand the dataset, they weren't necessary to analyze it. And therefore, I decided to drop those. And also the remaining columns were renamed. And then also I pivoted the data set so the date column became the index. And then more excessive columns were dropped that I found were unnecessary or weren't needed. And then the column names were also shortened for easier readability. And so as you can see, fine particulate matter became FPM, ozone, fine particulate matter, associated asthma, ED visits. And as you can probably tell just by looking at this, the missing values were numerous and actually caused issues with predictive modeling. I found out that you can't just leave them blank, because if you left them blank, the predictive modeling actually wouldn't work and it wouldn't allow you to use any predictive models. And so to fix this problem, I actually used the mean values of the columns as replacements. So I found the mean of fine particulate matter and replaced the missing values with that mean, and also find for the other columns as well. I really wish I would have found a better way to replace these values, but unfortunately there really was no better way that I found. And for the visualization, most of the values didn't really correlate with one another, which I found surprising. And then also, as you can see in the fine particulate matter trended downwards. And as for the hospitalizations due to asthma from fine particulate matter, it is obvious that my pre-processing screwed the data. It actually originally was trending down, but with the filling in the blank data, the blank data values with the mean, it actually created a flat plateau instead of the nice trending down that it actually was happening. And so I'm kind of very disappointed with this, but I really didn't find any other way to actually put in other values, unless if I wanted just deleted out the rows. Without it just left me with 4 values and 4 rows. So I just decided to replace it instead. And then as for the ozone, it didn't really have a pattern. Even with the plateau in some areas, it kind of just was all over the place. And then as for the hospitalizations due to asthma relating to ozone, it also had skewed values. And it also just didn't really have any pattern. It kind of just raised and then dropped, and therefore I decided not to analyze this, just because there really was no set pattern to it. And so for the predictive models, I did end up just using linear regression because it worked best for this model due to analyzed more numeric values instead of categorical values. And so I used both forwards elimination and backwards elimination, and then stepwise elimination. And then I basically just analyzed the hospitalizations due to asthma related to fine particulate matter. And then I further analyzed fine particulate matter to see if there were any predictors for it, to see if you can predict if it was raising or lowering. And so for the backwards elimination for fine particulate matter asthma-associated ED visits, I did backwards elimination. And as for the variables used, fine particulate matter, nitrogen dioxide, ozone-associated asthma ED visits, ozone itself, fine particulate matter associated deaths, and sulfur dioxide. And as for the best subset, it actually removed just ozone and left all the other variables. And as for the mean percentage error, it's not the best, but it's not the worst. And then as for the forwards elimination, the best subset was actually found to be fine particulate matter associated deaths and ozone associated related ED visits. I found this interesting because fine particulate matter was actually not used, or it was actually not in the subset, which I found interesting because it actually was related to fine particulate matter associated, like it's in the name, but yet it's not actually in the best subset. So I just found that interesting. And as for the statistics related to it, it actually was the same as the previous set, negative 0.0252, and so it's the same, which I found interesting and very odd. And then as for the stepwise selection for fine particulate matter associated asthma ED visits, it actually ended up being the same predictors as the forwards elimination. So the fine particulate matter associated deaths and the ozone as associated asthma ED visits, which as you can see, those are the statistics, same as before. And then I decided to analyze the fine particulate matter itself and see if there's any predictors for that. And as for the backwards elimination, the best subset was found to be nitrogen dioxide and sulfur dioxide. Which again, I found interesting that it didn't actually include any of the fine particulate matter associated deaths or ED visits. But I guess nitrogen dioxide and sulfur dioxide are air contaminants, just like, fine particulate matter. So it does make sense that if those increase or decrease, fine particulate matter would actually follow suit. I was interested to see that ozone was not included because that is also an air contaminant. But as mentioned previously, ozone didn't really have a pattern to it. It kind of just went all over the place. So I guess that's why it wasn't listed for this predictive model. And then for the forwards elimination and stepwise elimination, it pretty much was the same. Sulfur dioxide and nitrogen dioxide were both listed as the best predictors for fine particulate matter. And as for the implementation of the model, if I was to implement it for a business or into an organization, I would probably go with the agile approach because it's more flexible and you can actually move back and forth between stages. So if you, I think it's just more flexible, and for a model like this, you need a more flexible approach. And then I would probably further scrutinize the model when deployed, just because the model currently is not the best, and I feel as though it needs more data and more analyzation in order to make it actually accurate and just overall a better model. And then for the discussion, the highlights, I did learn about predictive modeling. The dataset was pretty interesting to analyze. And I also became somewhat good at linear regression modeling. And then for the lowlights, the dataset had numerous missing values. I tried to fill in the data, but it led just to skewed results. And then if I was to delete the missing data and delete the rows associated with it, it would lead to very limited data, only actually 4 rows. And so it was hard to create other predictive approaches for this data set due to that, and also just due to the numerical aspect of it, because I wasn't really analyzing anything categorical. And then I further went back to the website I had originally found this data set to see if there was any other information listed that I could use, or to see if there was any updates to it. And the website had actually deleted the data site off its site. So I was very disappointed that I could actually no longer go back to the original source and further find information about it. And then as for the lessons learned, basically examine a data set thoroughly before you actually use it. In hindsight, I would have looked ahead in the class to actually see what kind of to see what predictive analyzing is all about, and to see if, and I guess I just would have picked a different data set based on what I know now. Just because the data set I used, I did not like whatsoever, and it was very difficult to analyze and employ predictive modeling to analyze it. Probably is easier for someone with more skill and more knowledge, but at my particular skill and knowledge set, it was very difficult for me to analyze it. And so the data set again makes all of the difference. If you choose a good, easy to analyze data set, it's easy. If you choose a more difficult one, it is more difficult to analyze. And then pre-processing is key. It can make or break the predictive model. Again, if you pre-process horribly, it can actually screw the results and affect the data and the model. And if you pre-process correctly, it can make the predictive modeling so much easier. And yeah, that's my project.